at Mahindra and Mahindra. He served as senior manager and automotive industry domain lead at Latent View Analytics. With his unique blend of expertise in automotive systems and artificial intelligence, Mr. Senthil Murugan has been instrumental in shaping data-driven solutions and strategies for next-generation connected vehicles. We are truly honored to have him with us today to deliver his expert talk on connected cars. I now invite Mr. Senthil Murugan sir to take over the session. We request all the participants to actively engage and maximum benefit of the session. We welcome you, sir. You can start the session, sir. Senthil Murugan, sir.
Thank you so much. Good evening to everyone. Hope
sir, now you can share, sir. Senthil Murugan, sir. The PPT you can share.
Okay, let me. You can see my screen?
Yes, sir.
Yes, sir.
Okay, so hope I'm audible.
Yes, sir.
Make the slideshow, sir.
Thank you. Good evening to everyone.
Yeah.
I think thanks for your time. So the outline of this, information sharing or knowledge sharing or discussion, okay, is going to be revolving around two different areas of connected cars. So one part is, let's talk about the grains and sands of what actually is connected car at a basic level, fundamental level. And second part is basically slightly a new technology, which is the CV2X. Okay, so there are two parts to it. Okay, let's understand. So before getting into this, I think it is not just for connected cars. Now we are living in a world where everything is connected, right? So we order food through a connected solution, Swiggy's and everything. Everything is connected, right? So we book train tickets. Everything is connected. Train tickets or whatever. Social media. Everything is connected. So that means it is of no surprise for you that car is also connected. But the point is but there are some nuances to it. Nuances to connectivity inside the car, connectivity outside the car, connectivity around the car, compared to a normal mobile application. Let's say for a food delivery system, the nuances of ordering and tracking the order and getting it delivered and consuming and doing the payment, this is the nuances about. Whereas in the car, it's a mobile device. So there are various aspects like safety, security, and authenticity. So there are a lot of other elements comes into the picture, and also most important thing, privacy, right? So all these aspects come into the picture. So there are slightly different nuances. We'll touch upon that. So let's jump into this. So connected cars, as you can see, connected cars are basically trying to deliver use cases broadly in these categories. Basically security, safety, connected home, we'll talk about it, navigation, streaming contents, and roadside assistance, remote diagnostics. So security, the context of security is slightly different. If someone is tampering your car can identify and alert the owner remotely. So that is the context in which we should look at the vehicle security. And safety, it is very clear. Safety means your kids must be driving your car, or your friends may be driving your car. You will be able to communicate back to the vehicle about in the event things are not little rough. Okay, so that's a very unique. So that is the angle in which we should bring the safety. And there are multiple angles to safety. This is one angle, so that you can remotely influence what's happening in the car. Similarly, so on and so forth. I will not go into the details of every use cases. Let's jump straight away. Okay. So yeah, now I talked about there are two parts to the talk. One is the basics, nuances of real connected car. Second part is the advanced vehicle to CV2X. So actually, this slide starts with the part 2. This slide. So what are we talking when we say CV2X means car connecting to? There are multiple dimensions to it, which are mentioned here, right? So vehicle to vehicle communication, which is inter-vehicle communication, and vehicle to infrastructure, vehicle to internet cloud. We'll talk about it, and vehicle to pedestrian. So here in a road, when we are traveling, we are as a normal human being, we see cars in front of us, or we see bikes in front of us, or we see pedestrian in front of us, or we see the signboards, traffic lights. This is what we see when we drive, right? Now, how do we get ourselves connected to whatever we see and augment the driving experience is the next level of connectivity that we are getting into. Okay, just to slightly touch upon a couple of examples here so that you get an idea. So vehicle to vehicle communication means it's a self-explanatory, right? So first of all, with human eyes, we can see what is in front of us. Then you can ask me a very valid question: why do we need it? Okay, so human eyes can only see the line of sight. Okay, you don't know what's happening, what kind of a behavior the vehicle in front, two vehicles in front of your current vehicle doing, you don't know. But that braking in that vehicle can influence the subsequent cascading actions, right? So you're technically what you're doing, what does it make to do is you are extending your vision in a digital way. I hope I'm clear. Okay, so that's the value it's bringing in. So it's becoming us to see a bird view around the vehicle. Vehicle to infrastructure, you know very well, right? Infrastructure means anything and everything is infrastructure, right? So parking slots, charging stations, if it is an electrical vehicle, and this one, any malls nearby. So you can interact with those infrastructures, and you can exercise some of the use cases. Okay? And vehicle to network. Vehicle network is very simple. There are you can see, right? So you see in any streaming providers like Sun Next or Prime, they for a new user, even for Sony Live, for the new user they give some free period. Then you can after evaluation they can buy the subscription. So this is the trend in the Europe and US, that you can drive through a zone where you will be you'll be freely accessing the streaming platforms. Okay, and obviously the news and so on and so forth. And vehicle to pedestrian. Nowadays, everyone carries a mobile phone. You know very well. Now, mobile phones, if compatible to the necessary standards, can actually publish a data to the network. When I say network, means cellular network. I mean, the car can fetch the necessary information from the cellular network and move on so on and so forth. So you can ask me very well the same question. Why do I need to know about information about pedestrian? Because I might as well see it when I'm driving it, right? So then why do we bother? So this is where it is. We have vehicles are becoming complex. Vehicles are becoming bigger. You will not be able to see all the angles, corners of the vehicle. That is one. Second thing is you don't know when in the middle of the intersection, you don't know what is the other side of the situation. So again, the fundamental purpose is vehicle is becoming like an octopus with infinite legs or infinite touch points, I can say, through this technology, so that you are connected to everything. Okay, so this is the premise. How to realize this, we will talk about it. That's what coming now. So this is but before we understand the nuances, we need to understand the fundamentals of what is the vehicle connected to, what is required to realize the fundamental connectivity. Okay, so far so good, right? You can stop me whenever you want. So far so good.
Sit.
Okay, fine, thank you. Yeah, let's now talk about it. So now, before we look outside the cars, right, which we discussed in the previous slide, let's look inside the car first, which will enable us to look outside, right? As you can see, what you see is a standard or a typical vehicle communication network, which you might be already aware, right? This is for those who was not aware. As you can see, there is a telematics control unit. IVA is an infotainment control unit, and there is a gateway. And this is braking system, engine management system, and so on and so forth. This is illustrative. Now, you can clearly see, right? Telematics unit is the one which talks both inside and outside. As you can see, there is an antenna is connected to it. So let's go a little. Let's peel the onion one more layer. Okay. Now we are getting into. So now what we are seeing is so telematics unit how different it is from other vehicle controls is basically it's talk to both on board as well as off board, as we call it. Okay, let's move on. So now, inside the telematics unit, there are two worlds to it. Okay, there is a co-processor which takes care of the communication, and there is an application layer process, and they both are connected via serial communication. Right now, this is very typical architecture in most of the embedded systems where you have a co-processor existing. Now, you may ask a few things. The logical grouping of the peripherals, that is GPS, eSIM, Wi-Fi, and Bluetooth, and LTE. Now, so they are all related to wireless long range communication in nature. For example, eSIM is nothing but basically a network connectivity. GPS, you know very well. So this all grouped under the communication process. The software structures, layers, and processing strategies are totally different for this. Because, for example, GPS. So to triangulate a correct location of a vehicle, you might have to run some different algorithms. Right? Similarly, eSIM, to latch the vehicle to a necessary network, you need to have a different logic to it. Wi-Fi is very clear. Wi-Fi, there are a lot of scanning and pairing, and you have an entire layer of software is there. Same for BT, same for LTE. Now, whereas on the other side, if you see, this is a different world. Application processor. Application, I think I don't need to explain. Whereas you see gyroscope, accelerometer, backup, battery. We'll talk about what is backup battery. Now you see these are all about the car, inside the car. So accelerometer will gives about the acceleration status of the vehicle, and gyro, you know the gyro value, you get it. And these values are going to application processor. Now I touched upon one use case in the beginning, right? So when someone tries to tow your car or someone tries to tamper your car, these sensors will sense it and alert then it will act as a wake up. Then the rest of the communication is triggered. Okay. So this is there are, so from a software point of view, from a hardware point of view, any questions?
സെൻസിറ്റീവ് പിമ്പിൾസിയുടെ പോരാട്ടത്തിൽ കഷ്ടം പുതിയ ഗവൺമെന്റ് ആംപ്ലിഫൈഡ് ജെന്റിൽ ക്ലെൻസർ ഇത് പരിസരയുണ്ടാക്കും 99% ക്രീമുകളെ എതിർത്ത് പോരാടുகிறது സെൻസിറ്റീവ് സ്കിന്നിലും
I'm hearing everything is okay?
Yes, yeah, proceed, sir.
Yeah. Okay. Okay. You can see my screen, right? Okay, fine. So, so that is the mindset we should have. So there are two worlds of processing. Like I mentioned in the beginning, telematics control unit talks to both inside and as well as outside. That is one difference compared to the conventional. And second thing is there are two different worlds of processing. Okay. And let's move on. Let's peel the onion, slightly focused on modem. Now let's focus on only on the external world communication. So we have a modem, right? And eSIM. Now, this is important. So we all have a SIM in our phone. Similarly, every vehicle will have something called eSIM. This is not the same. It is almost similar, but not same. There are some slight nuances are there. Okay, which we will talk about it. Okay, so you can parallel. Probably to make it simple, right? We know when we buy a service from, let's say, an Airtel or Geo or something, there's a verification happens about the customer. They give you SIM and they register your credentials. That means your name, your Aadhaar number, or something, or address proof against your SIM number to the service. So you see there are three parameters. One is identity, another one is the service, okay, another one is the authorization. So that is exactly what happened here also. So that is what we call it as a SIM registration. So SIM registration, network registration, and whitelisting we'll talk a little later. We'll pause it for a moment. Exactly same thing, but slightly different. So now eSIM, you might have seen the eSIM, right? So this is the on left. What you see is the normal SIM, which we use in our mobile phone, right? Mini, micro, nano SIM cards nowadays came. So this is the form factors used. So this is the eSIM. As you can see, it's very small. Even nowadays, the eSIMs are becoming smaller and smaller and smaller, and becoming like a small integrated circuit in the PCB itself straight away. So that is that's how the eSIM is actually. Okay, now, eh, okay, let's move on. So why embedded SIM? Why not the classical normal SIM? Okay, so this eSIM is expected to. Okay, this eSIM is meant for not the normal calling and commercial purpose. It is meant for embedded application purpose. So the bandwidth is restricted for this. Number one. Number two, it can only communicate to the prescribed. Let's say for example, Airtel. The SIM can within the service provider. There are different node points through which only these requests are processed, not by any public. So that this is logically bifurcated to avoid any replay attack or any spoofing, such things. Okay, so that is the purpose. It is tagged as a eSIM, and so on and so forth. And also it's an M2, machine to machine communication, by which I mean infrastructure to infrastructure. We'll talk about this a little later as we move on. So let me pause here and recap. So we talked about telematics unit as such, how different it is compared to the other vehicle controls. One, then when we enter into the telematics, then we see there are two different worlds. One world processing the peripherals, which is basically connectivity purpose. Another world which talks about the application processing. Then we went ahead, and for the connectivity purpose, we need to have an eSIM, okay, not the conventional. And we just now talked about eSIM related features or facilities and so on and so forth. Okay, let's move on. So if you look at it, so this is the communication flow. I think it's very straightforward. Let's not. I think I touched upon this in the previous explanation itself. Let's move on. So how does the device communicate to the end user? Okay. Now, now what happens once the data? I request you to focus on the right hand side of it, because left hand side we discussed. We'll talk about what is MQTT HTTPS, which I think you might be already knowing it. We'll talk about it. So on top of it, on the right hand, what you see is connected car cloud. Like so, so the end user will be carrying a mobile device, and as well as the car. So we have stakeholders are the end user will be carrying a mobile phone. End user will be actually accessing from a website also. From the website also you can understand what is your car status, so on and so forth, and also your vehicle. So these three endpoints need to be served. Okay, and that is all served through a cloud environment. And what is this cloud environment contains is basically, it is basically going to have an inflow traffic from the car to the data storage, and from there the application runs in the. We'll talk about in details. We'll talk about the subsequent cells. So from the cloud, your endpoints are served. Okay, MQTT is nothing but a multi-queuing. You know this, right? Telemetry transport protocol. It is basically the publish subscribe type of a protocol. It is very simple, straightforward. Okay, and on top of it, very very important. And in that entire communication from the vehicle, on the left what you see is the vehicle, on the right what you see the cloud. Okay, this entire communication is protected by a security. So it's called as a transport layer security. I mean multiple layer of security, but transport layer security is one level. So this is how it works. It's normal. So I think it is normal. Any web to web application security same. Let's move it. For the simplicity, let's not go deeper into this. Okay, like I mentioned, how does MQTT communication? It's very simple. Client and broker. So subscribe, publish. Say just for example, let's say your car has thousand data points. Say for example, engine speed, engine temperature, door status, oil status, lamp status, and fuel information. Like this, there are multiple informations about the car is available to be used. Whereas on the end device, mobile device or the web application, you don't need all the data to be flowing at same, all the data to be flowing always. You only need the required data to be flowing. So basically, that is where the publish and subscribe framework comes into the picture. Okay, so this is followed everywhere. This is also, there's a lot of cost involved because there's a data cost, right? From the car, we send how many bytes, how many data traffic goes. It's all charged. So from a commercial point of view also, so the data traffic has to be governed and serviced. Otherwise, it will become commercially viable. Sorry, commercially not viable. Most of the, in a practical situation, the real struggle in the industry is basically the cost of the data. It may be surprising to you, or you may be aware of this. So the use cases are keep growing, even though the internet is becoming available. But still, the data charges, not only data charges charged by the operator side, the storage, the cloud cost, right? So overall, if you put end-to-end cost, right, it is a normal mobile user cost, you can multiply it by some 3x or 4x time because of the pipeline processing and storage and management. So hence, the cost is a very sensitive component here. Hence, this MQTT communication actually allows us to filter the traffic and manage the traffic. I think I made my point. Let's move on. So I think I talked about mobile devices and website. Okay, so these are all the endpoints we are getting served. Okay, now it's a simple thing. Now putting it all together, whatever we discussed till now, putting it all together. So you have a vehicle, TCU. We know what is inside the TCU. There is the eSIM and the peripherals. All those things are there, and the eSIM hooked up to the registered network, and network to network communication and network to cloud communication. And from the cloud, the customer is served through various endpoints, through mobile or website, web application. Now, let's take a simple use case. If you want to find a car where you are parked, okay, let's say this is the car you have parked, right? So what do you do? It is very simple. You take your mobile phone and you start. There will be some application will be there in your car. You have to find out where is my car. What happens is that there is a MQTT request goes to the cloud, okay, which basically just tells find my car. That means this user and car, everything is mapped together and maintained in the cloud. Again, it goes there, and it targets the necessary TCU. And again, the information, this is GPS latching and everything happens. Then it goes back and the data goes. Remember, your vehicle has to be in totally power off condition. Otherwise, your battery will be drained, right? Or otherwise, it will be extremely low power mode, right? So this cloud HID acts as a wake up to the peripheral unit, which we talked about in the beginning, right? So your application is actually sleeping in this condition. You park the vehicle and you moved on. Okay, this could happen in days, right? After 10 days also, you can find out where you parked the vehicle. So what happens is, your like I discussed, your peripherals will be active at a very low polling frequency of the interrupts. On the other side, once it happens, then it wakes up the application, and the entire vehicle wakes up and does the necessary processing. Then it sends the data to the cloud. So the key consideration here is basically the battery storage of the car. Okay. Otherwise, you end up draining the battery. You lock the vehicle, then it's become a very painful experience for the customer. Okay. So that is a practical problem that we have to deal with it. So the power management of the vehicle is a very, very crucial component. Let's move. This is nothing but the steps which I have just now explained. Let's move. Let's take another exercise. Let's take another scenario of the flow, right? So if your car is getting towed, let's say someone is without your knowledge, someone is towing the car. What happens? Like I mentioned, there is a gyro. There is a gyro will act as an interrupt, and it'll be published. So it will be published that the vehicle movement is detected. So the application will find that the vehicle is moving without ignition is on, without the so it can sense it. Then it publishes the status and back to the customer. So the customer knows about the situation. So what is the difference between the previous use case and this use case is that in the previous use case, it is the customer or the endpoint is requesting for the vehicle info, which means from endpoint to the source. Whereas here, you see the source automatically triggering it and alerting it. But the overall communication and workflow, everything remains same. Here, I think, sorry for this, nowadays they have become 5G. Okay, so let's move on. So hope it's clear till now. Now, okay. So again, let's take a let us bring another component, which is the cloud. So this is the theoretical slide, which I don't want to talk so much about it. But however, most of the car manufacturers, everyone will use infrastructure as a service. Okay, so there are solutions available where you can plug and play. There are some partners or some startups or IT organizations. They actually develop the entire service to talking to the car, talking to the mobile device as a entire solution. That is called the platform as a service. Okay, and infrastructure as a service is very clear. You buy barebone compute, barebone storage, then you build on top of whatever the applications you want to build. That's an infrastructure as a service, that's what most of the OEMs does. I think almost all. I don't see anyone who is using the other two. Okay, let's move on. So why cloud? Very clear. It's not. You could have used anything. You can use any server. Actually, technically speaking, why cloud is as the vehicles are getting produced, you don't know how many vehicles, how many volume you are going to build up, and also you don't know how many hours the customer will be using the car, right? So when the vehicle is running, driving, you're actually continuously you are pushing the data. So you're actually unable to predict the volume of the data that is inflow, which is flowing into the cloud, which is flowing to the server. Hence, the classical systems like a standard server and everything comes to the centralized location and process it from there doesn't work. So we need a scaling. So we need a scaling of memory, compute, and so on and so forth, and we need agility. That has to do quickly. It should happen, and also it has to automatically should happen, right? And also disaster management means when it is in a cloud, we can actually configure the regions so that multiple regions that your data is backed up, so on and so forth. Now, like I mentioned, though it offers offers the system scalability, but it comes up with a cost. Even though it's a low cost, but it's a significant cost. So this creates a 1x component of cost, and the previous the data cost is becoming another x. So combining together, it's a 2x. So we have to be very mindful about the traffic, and we have to be mindful about the scalability of this. So most of the connected solutions fails because of the cost unsustainability. Okay, let's move on. So now putting it all together, we are building one level inside the cloud side. I think very simple. So we're from the vehicle network, like MQTT broker, like I mentioned, right? MQTT client would be there, client and server both would be there. So for whatever the vehicle data comes into this is filtered by this MQTT broker, and it is stored for the data science applications or AI applications and so on and so forth. Now you might be asking why we need to have a proxy. We'll talk about it. Okay, and you might be wondering. There are a lot of SMS. Bulk SMS we used to send it, right, from a car manufacturer saying that your car has so and so updates, so on and so forth. So for the bulk updates, we need to have a SMS service provider where we have to use it. And mobile application, very well clearly, right? And third party applications. Third party applications means navigation is a third party application, which means as a Mahindra, we actually have to procure the navigation maps from MapMindia or Google, and we have to integrate it in our mobile apps and so on and so forth. Okay, so like this, we have so many third party. One example I've given is the navigation. Like this, many media. We have another app called this one. What do you call that? Explore. Thrilophilia. We call it as a thrilophilia. It talks about when you drive a car, when you stop the car in a particular location, it tells about what is so special about this location, right? Again, it fetches from the cloud and itself. So the use cases are plenty. Let's move on. Okay, now this is slightly one layer below. Like I mentioned, now we are talking about the big data processing. Now, so now you can see it's a very busy slide. Let me put it in a very simple way. Okay, so this containers versus serverless computing. So all the applications which are hosted to the cloud, for example, I'll give you an example. So let's say your vehicle towed alert is the one application. So that application is contact, but the same application running, but it has to serve so many connected cars in the world, right? And so the detection, so like I mentioned, the data flows from thousands of cars into the cloud, right? And it has to serve thousands of customers, and the both side customers are growing. So there is a small container has been built, okay, which will only identify this event. Okay, that's a container in the simplest form. Then the rest of the downstream applications taken care by other layers of execution. Okay, so we have, I think most of the cloud platforms will use containers for every area. Like I mentioned, this Toad service is one application. Like this, many applications are built as a container, independent containers, and hosted in the cloud, and it is served. Now, another important information is a proxy, right? Uh, in an embedded environment and in a vehicle environment, the number of IPs are fixed by fixed. We cannot exceed the number of IPs. This is the regulation from the Department of Telephone Department of Telemetry Communication, right? So DOT, Telecommunications, Department of Telecommunications. So we only have 100 IPs to 100 IPs maximum allowed to use. But however, we need to use so many. Whereas in our normal SIM card, we can browse any website, we can use any, we can reach out to anywhere, anything, right? Because it's eSIM, it's like I mentioned in the beginning, it is restricted, it is protected, and it is processed through a different channel. Now, however, what if your applications are accessing which is outside the allowed 100, then that need to be prevented. So that prevention is is what this proxy is doing. There are two ways to do it, the proxy. One is reverse proxy and forward proxy. Okay, so forward proxy is nothing but the person who is requesting the domain access, okay, has to be verified and forwarded. Otherwise, it is rejected. Reverse proxy is the other way around. The origin server, I mean, the request is passed through. Once the origin server start responding, then you have a reverse proxy where it blocks the access back to this. So both have advantage as well as disadvantage, but that is outside the scope of this conversation. Let's move on. Okay, now let's take a pause. We're getting into the part two of the conversation. So till now, let's recap. Let's recap. Till now, what we have seen is what are the components that is required to build a connected car solutions. Let me go here, right? Yeah, let's stop here. So what are the components that is till now? This is what we have gone through. So there is a TCU required, and there is a eSIM, and there is a two processing worlds, and eSIM is hooked up to the uh, telephonic service provider, I should say. I should say a service provider, and service provider to service provider communication happens, and the data goes to the cloud and the mobile devices. And cloud, inside the cloud we talked about applications, containers, storage, and scalability. Now you need all these pieces are have to be put together to actually deliver the use case to the customer. And also I touched upon the cost as one of the most sensitive component. uh, Also I talked about the traffic, the data traffic management, and so on and so forth. So now you have an overall overview about what it needs to realize a full connected car solution framework. Now, with this, we started the conversation. So, with this background, now we are heading into the advanced connectivity concepts, which is the CV2X. Okay, great. So, so far so good, right? Can I proceed, or should I pause for some questions?
So question we will have in the sir.
In the end, okay, great.
And we will end it. Keeps.
Okay. So CV2X, okay. I think I touched upon this in the very first slide, which I talked about it. It is basically vehicle to everything outside communication, infrastructure, car, person, network, so on and so forth. So we call it as a V2V, V2I, V2P, V2N, which we talked earlier. Now let's move on. Now, this is one example. Let me play one small video here. Okay, this actually really happened. Why do we need a vehicle? I mean, communication. You can see here, it's a Lamborghini. Lamborghini is going. It is trying to take over. There is another car. Is there? There is a Ferrari. You see, it's pushed up. Now, what happened here is, not sure whether you are able to recognize the impact. Let me pause here. Can see there is a one vehicle, there is a truck which is blocking this road, and here there are multiple vehicles are getting queued up. All sorry. So multiple vehicles are already getting queued up. Okay, but the driver who is coming from the behind thinks that there is only one vehicle. So he was trying to outmaneuver, but there is a vehicle in front, and unfortunately the vehicle coming from the behind hit, which is impacting the truck. So what is the fundamental message here? The fundamental message here is driver do not have the vision of what is ahead. Driver only see what is in front. Okay, hence which is resulting into that information loss is resulting into some unwanted scenarios in the road. So let's look at it. How can avoid this such situations? Let me. So the same situation. You have a truck. Okay, there is a car going, and this car trying to take this one, trying to take this one. But similarly, at the same time, there is another car is also coming. Now, two things should happen. Okay, either this car should slow down, whatever I'm touching. Either this car should slow down, thinking that this car might come, or this car should continue this path, thinking that this car will go on. Now, what happens? Now, how do they both? But who goes here is the arbitration that we need to follow. And remember, this car also going at a high speed lane in a fast way. This car is also going at a fast lane. So now this is where it comes. This driver is at the disadvantage of this car being found in the blind spot. It is possible. It is possible that this car can be a blind spot of this. Hence, the vehicle to vehicle communication helps. There is a vehicle in your blind spot which is approaching so fast. Exercise caution. Such information can be published to the driver here, so he takes the conservative action. Right now, let's take a. I also talked about another use case. When you have a high speed lane and a high speed drive, when you have back to back cars going, the hard braking applied by this truck will make the reaction time of this driver is very less. Reaction time of this driver is even very less. Reaction time of this driver is far less. We might end up, so as we go, every driver is blinded because at least this driver is seeing there is a braking. But as and when by the time he reacts, he eats away this driver's reaction time, so on and so forth. So now there is a danger of rear collision will pile up. So such use cases, such scenarios can be avoided by understanding the safe distance between the vehicle in front for this vehicle, for this vehicle, for this vehicle. We can do that. So such use cases can be done. Similarly, at the intersection, right? So you are approaching the vehicle this way. There is a vehicle coming here, or there is a vehicle coming here. You are about to take a left hand, but you don't know whether what is the situation on this road or what is the situation on this road, opposite side, right? So such interactions and coordinations can be realized. through this. Okay, let's move on. Okay, now I touched upon this. So basically, CV2X allows us to have a non-line of sight. Non-line of sight means basically the objects which is not in your straight vicinity, right? Whereas you can ask me, nowadays the vehicles are autonomous, so it should start braking automatically, it should start accelerating automatically, so on and so forth, right? So this entire autonomous systems, which is ADAS systems, which works only depends on the camera which is fitted in front, cameras surrounded by the cars, and so on and so forth. Which means the visibility of the autonomous software stack or autonomous control system is restricted to 100 meter worldwide as of now. So it is like a normal driver. I mean, not normal driver. It is just 100 meter only visible. That directly puts the restriction on the maximum speed that you can go, right? So it cannot look beyond. Whereas CB2X allows you to go beyond and exercise caution. That's what it is. Now, the important thing is that, like I mentioned, it is a CV2X, that is cellular communication, cellular vehicle to vehicle communication, which means there has to be a dedicated spectrum allocated for such applications. Now we have, as you can see on the left, we have in US it is 2003 the spectrum is allocated. European Union, Japan and Korea and China, they all have a spectrum allocated. In India, uh, it is not yet allocated. The spectrum is not yet allocated. We are waiting for the notification to come. We are talking to ministry from our side, from Mahindra and Mahindra side. We are pushing the government to get this spectrum allocated, and there is a lot of contradicting values between the operators. When I say operator, means network operators, Airtel, Geo, and so on and so forth, right? And the OEMs and the government. So all the three people's intentions are actually contradicting to each other. Hence, we are unable to come to the consensus. So hence, in India, it is still getting delayed for realization. However, let's move on. So let's look at some of these cases. In our vehicle, we have implemented in some at a concept level, but we are trying we have taken to ministry. We are trying to push it. So, like I mentioned, I think we talked about this. I think it is self-explanatory. I don't need to explain, right? So you have a heading vehicle, an ego vehicle is coming, and another ego vehicle is going, and you don't know this car. It is going to come. It is going to take a right turn, or it is going to take it to this junction. We don't know, but depends upon you. You don't know what speed this vehicle is also coming. What speed this vehicle. This complicated scenarios will be well maneuvered. Will be well maneuvered with the use of all connected systems. As you can see, you can see there is this is the vehicle screen. What you see is a vehicle screen from our one of the vehicle platforms. Such scenarios are identified well ahead. Here itself, not here, well ahead, and mentioned. It is mentioned to the customer that there is a vehicle which is likely to hit if you continue. So that is what the warning here, as you can see, right? So such use cases can be realized using CV2X. Let's move on. Similarly, like I mentioned, rear collision. So it is very straightforward use case. I don't need to explain. Okay, the safe distance, because this car will be moving at some speed. This car will be moving at some speed. So what is the difference? Is the distance, safe distance. The distance can reduce, increase. As the distance becomes lesser than the safer distance, which is defined here, right? Safe following distance, the warnings are set. Now, you can imagine the software complexity, right? To do this, there is a lot of algorithm need to be executed in this car and this car as well. So another important thing is the compute power that is required inside the telematics unit, or it is required inside the car, is very, 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 very crucial. And that is also one of the critical. And when I say compute power means, that is also means cost. So that is what a crucial component. Let's move on. And this is signal violation. So, like I mentioned, vehicle to infrastructure communication also over there, right? So infrastructure includes the signals. So in the event, if you did not pay attention to the signal, or if there is a vehicle which is blocking your view to the signal, right? that can be communicated, and it can be the exact signal status can be put in front of the customer, and you can see it. So this is a very useful value. Sometimes the signal is not visible. It is blocked by the vehicle in front, or it is too bright to see, or it is raining, so on and so forth. Such situations it will take care. Now, let's move on. Now, I talked about security. There are many things can go wrong here, right? So here we are talking about car-to-car high-speed communication, car-to-infrastructure communication, and if there is a manipulation happens in this system, then we are in for a big soup. So there is a lots of regulations have been rolled out, not in India but in Europe and US. There are a lot of similar mechanism. The centralized key management system, centralized authorization system, and remember, it is not just let's say one car maker versus another car maker. All car needs to talk to each other. So you have a lot of interoperability. So there is a central security credential management system need to be established, and who does that is actually the ministry who has to run this. So we don't know who is going to do it in India. We don't know. Whereas in other countries, it is the ministry who takes care of this, so that every OEMs operate in a very seamless way. Okay, let's move on. Okay, so India is a very peculiar situation compared to the European market. So this use case, whatever I have shown, are very beautiful roads, very well disciplined roads. So then also we have a problems which I shown in the video in the beginning. But whereas in India we have a unique challenge. Unique challenge of total. I should not use the word chaos. Multiple variables on the road, right? So you will have a two-wheeler just crisscrossing the road. You also will have a cows on the road. We also will have the people who is selling bananas on the road. We also will have ambulance and other big vehicle lorries and big vehicles in the same lane, unlike the Western world. So implementing CV2X in India is a big challenge. Okay, but however, it's a great opportunity. So what we have done is, let's look at it. So this is the roadside unit. So this is what actually fitted in signals, in pillars, in traffic systems. So this has its own tower. It has its own camera. This is called roadside unit. Okay, there are a lot of companies who started making this roadside unit in India nowadays. Let's move on. So okay. So now, like I said, right, in India, it is in the policy state, in the policy level at the government. So we are looking to push the things forward. The companies like Mahindra is constantly pushing the government to get it. But there should be a reward for this, right? There should be a reward. But what this technology offers? This technology offers a safety. This technology offers a security. Hence, while giving the safety rating, if someone is having this technology, it should get a better rating. So that is the kind of conversations we are having it with the governments, but it's still going on. Okay. Now this is a demo which we have done sometimes back. Okay. So you can see, right, emergency vehicle alert. I think I've explained that. Emergency vehicle alert and traffic light warning. We spoke. Front collision warning. We spoke. Hazardous location. Hazardous location means, right, in India there are a lot of places will be opened up in the road, or roads become two lanes to single lane to half lane because someone has digged some hole on the left or right. So these are all hazardous situations. Now, so such situations can be communicated to the driver early. Okay, intersection we talked about, roadwork information I just now explained, right? So this is what we have demonstrated to the customer. Now, this slide, let me put it very simple. So we have driver assisted systems and autonomous systems and L2 autonomous systems in our car. Why do we need CV2X? As you can see, some of the use cases which can only done by CV2X technologies, which are not done by ADAS, not possible to do by ADAS. Some of the things can be realized by both, right? So now, how do you see this? So CV2X as a co-pilot or a complementary technologies to the existing ADAS to realize the features, safety features. So that's how we are seeing it from industry point of view. So, like I mentioned, this is my last slide, by the way. like I mentioned, this is the in India it is not licensed. The spectrum is not yet licensed. So we're trying hard. All the OEMs are trying hard to get this spectrum allocated. Once the spectrum allocated, we have the technology to realize it. So yeah, so that's about it from my side. Thank you, team. Any questions? I'm happy to take. Hope I have given some useful information.
So audience, you can ask any queries.
We have about 13-14 minutes, I think. Any questions? I'm happy to answer.
You can keep it in chat box also.
Yes.
Participants,
Yeah. Hi.
Sir, can you please tell us about this container and hypervisor, sir? Like, why do we go for this particularly?
Okay. No problem. So it's very simple. I think I will slightly briefly touch upon it, right? So this, let me go back to this. You're able to see my screen, hopefully.
yes sir, yes sir.
So now, why do we need a container, right? Now, like I mentioned, you imagine the situation, right? So what is the dynamics here? The dynamics here is we have some lakhs of cars in the market, right? Each are talking to the cloud, right? And we have similarly lakhs of customer. They are also talking to the cloud. Now what happens? Containers is an application which is specific to do one particular job, right? For example, every customer cannot be tracked, right? And one single application cannot understand every customer and process the request accordingly and respond it. It will become it become a computation point of view, it becomes a very, I would say, inefficient way of doing it. So they will break into pieces which are fit together. So the first piece in this example, whatever I was telling, is the user management piece. User management. So you know, right? In AWS, we have the multiple components are put together to form the real use cases, right? So containers is so basically the first two layers are basically data engineering components. When I say data engineering means there's a multiple data inflows are coming, and you have to divert that inflows to the right use case. Right use case. Some people want to know understand about the door status of my vehicle. Some people want to understand the fuel information of my vehicle, and so on and so forth. Right. So now this, but not every action need to be done for every person. Only the dedicated action need to be done. So which means the dedicated containers need to be called. Dedicated containers need to be triggered for the dedicated user so that it is served. So the containers are nothing but a piece of application that only does the minimal application. So
Sir, actually, we have used in Django. Is it the same? We talk about this Flask and Django we have used in this container.
Django you might have used it. Yeah. It's slightly different. Flask and it's slightly old, but in the AWS world, we call it as the container, the elastic services. You might have heard, right?
Sir, and one more question. What is the need of eSIM here?
Very good. eSIM is actually similar to the SIM which we use on a regular basis, but the different here is this is used for embedded purpose. What does it mean is our normal SIM is exposed to all the networks and all the operators, right? Anyone can call your number, right? Any service provider can call your number. Geo network can call Airtel network, and Vodafone subscribers can call Airtel network, and so on and so forth. So it's a matrix, right? Whereas in embedded SIM, only a dedicated providers can operate the request and so on and so forth. And the bandwidth, the frequency is slightly different. The bandwidth and frequency, operating frequency is slightly different for the security reasons, because you cannot mix the request that is the the telematics request which is coming from the car to the normal traffic, so that there is a chance of spoofing, replaying, capturing, so on and so forth, right? So to prevent that, you have to have an eSIM. Okay, you have to that eSIM allows you to operate in a particular frequency, particular bandwidth. That's all.
Chat box, some questions are
Thank
there,
you,
sir.
sir.
Okay, some questions are there in chat
Yeah,
box.
yes, sir. Yes, sir.
Can you please share the feedback? Okay, okay, sir. Thank you so much. Okay. Is ADAS in the cars and CVT? No, different, totally different. Okay. So let me tell you, like I mentioned, right? ADAS. So the fundamental purpose of ADAS is basically alert the driver, brake the car, control the accelerator, right? These three, right? Alert the. Okay. Now that's all. That's about it. Now ADAS, we have a L1, L2, L3, L4 ADAS, right? So I think in India we have reached up to L2 level. ADAS is basically a vision-based system now, vision and radar combined-based system. So when I say vision-based systems, then naturally the natural limitation is that the range. So your cameras, which is fitted in the car, can can faithfully detect up to 100 meters. Now, so that means your entire use case is built within that 100-meter bubble around the car. Whereas CV2X, the technology is the very word CV2X is cellular vehicle to communication, which means you are actually using a network to understand the world in front, which could be 500 meter, which could be 1 kilometer, which could be 2 kilometer, which could be 3 kilometer. So the range in which you have the control is extended by a cellular communication. Whereas in ADAS, it's just a camera which is sitting in front of the car, which sees the road. So that's basically the difference in the fundamental technology. And like I mentioned in the last slide, the use cases, what it is, let me put it again. You're able to see my screen?
Yes.
So yeah. So you can see, right? So the use cases which is realized by CV2X is different. Some of the use cases are only realizable by CV2X because of the range. Okay, so this I think I've shown. Then you're asking about cyber security management. Oh, okay, very good. Now, I think there are two things. Every request which is goes from vehicle or from end devices is protected by the transport layer security, where there is a key. You know, right? It is any TLS 2.0 is the security standard which we follow. You can Google it up. So that's how it is. Can you please, and what is the next question? That question is came. Any other questions? Please share the preview. Okay. Thank you. Any
Any other
queries?
queries, participants? Any other queries? Participants, any queries?
Sir, do we have any kind of standardization for V2X with respect to 5G environment, sir?
Correct. Yes. We like I mentioned, in India it is not there. Okay. But in Western world, yes, there are standardization. There are, when I say standardization, by which I mean the defined bandwidth, defined KPIs, performance requirements, all governed by governments. It is there. But in India, it's still evolving.
Thank you, sir. Thank you, sir.
Any other queries?
So can we simulate the kind of environment, any particular tools you can
Very good
use?
question. Very good question. Yes, it is possible. It is possible. There are a lot of network simulators are available. Okay, you can actually recreate the scenarios of roadside unit of another connected car. So there are a lot of simulators are available, which are very high cost actually equipments, but it is available. We can
First O வச்சு நான் சொல்லிடுறேன். OA plus OB is greater than AB. இது முடிச்சாச்சா இந்த triangle? அடுத்தது இந்த triangle.
Any other questions?
Any other queries? Shantipriya madam?
Sir,
So shall we conclude?
okay, sir. Participants, any doubts? Anyone? Okay, sir, we are concluding.
Yeah.
On behalf of Department of ECE, Vidyajyoti Institute of Technology, our sincere thanks to Mr. Senthil Murugan, sir. We are deeply grateful for the time, effort, and valuable insights shared with us, like vehicle level architecture, telematics of connected cars, eSIM and cloud server communication, cellular vehicle to everything, and different scenarios. And thank you so much, sir, for clearly, clarifying the doubts. We also thank all our participants for your active involvement. Thank you all. Please fill the Google form shared in the chat box. Thank you. Thank you so much. Thank you, sir.
Yeah, thank you, sir.
Senthil Murugan, sir, once again, thank you so much.
Thank you. Good night.
Thank you, sir.
Thank you, sir.